All right, so today you'll see in the prove statement, prove it's a parallelogram. Now, if you guys are on day 4 here with me from your notes, day 4, you will see 5 ways to prove a parallelogram, 5 ways. I'm not a big fan of reading those off to you. I'm not a big fan of trying to explain it to you. What I am a big fan of is actually showing you a visual representation of what I'm talking about. Okay, so what I have up here right now on your screen, and you don't have to copy this down, it's not anywhere in your notes, but I want to make sure you guys see it visually, are 5 quadrilaterals. And I'm going to put markings on each of those 5 that make it into a parallelogram. The first and most common way we'll see to make it into a parallelogram is this. If I can show this right here that I'm marking on my diagram. Both pair of opposite sides congruent. If you can show me both pairs of opposite sides are congruent, you got yourself a parallelogram. Way number 2, instead of showing those opposite sides are congruent, show those opposite sides are parallel. Do you guys notice I'm just showing one of the properties exists? That's all I'm doing. I gave you all those properties a couple days ago on Friday, making sure they exist. So opposite sides congruent, opposite sides parallel. Next one, opposite angles congruent. Now, here's the important thing about this one. You need both pair of opposite angles congruent. One pair won't cut it. You need both pair congruent. That gives you a parallelogram. I could do this. Remember our good old diagonals? If on the diagram you could, I don't know what the heck that is. You could do this. Show me these 2 pieces are congruent. And then show me these 2 pieces are congruent. Diagonals bisect each other. If you can do that, you got yourself a parallelogram. So far, these 4 diagrams I'm showing you are just the properties. Now, here's where you got to focus in. There's also a special case you could do. You could also show a special case for me, which is the following. And this is number 5 in that box on your notes. One pair of opposite sides are congruent, and that same pair of sides is also parallel. If you can do that, what I'm showing there in diagram 5, that's a parallelogram. So these are the 5 ways today we're looking to make a parallelogram. Okay, these are the 5 different ways we have available to make a parallelogram.
I remembered a question that it wasn't really on the homework, it was separate, but it came up when I was working on the homework. Do diagonals always bisect the angle?
No.
That they're at? Oh, all right.
That in a parallelogram, no, but one of the special parallelograms we'll talk about on Thursday, Sophia, that will be a yes to that question, but not for a parallelogram. Only thing the diagonals do are bisect each other. That's it. Done. Okay, so here we go. Before I hop right into a proof and throw you guys into the fire, I'm going to give you some information about a quadrilateral. And I want us to figure out, is it enough information to say it's a parallelogram? So look at number 1. I gave you guys quadrilateral SMTP. That's all it is a quadrilateral. That's it. 4 sides. First thing I'm going to tell you, SPX. So let me take a look at that angle. SPX is congruent to TMX. Those 2 angles are congruent. Everybody stop. Don't look at the other given yet. Look at what you've marked on your diagram. All right. We are a quarter and a half into this year. If you know those 2 angles are congruent, you should tell me something else is true right now about that diagram. Where we are at this point in the year. If those 2 angles are equal, they're special types of angles, you should be able to tell me something else about that diagram that's true. If those angles are equal, tell me something else. And here we go. Unfortunately, you can't see the numbers being done, but I'll let you know what comes up here. Okay, let's start right off the top. Vinny, you're up. If those 2 angles are equal, do you know what type of angles those are, Vinny?
Alternate interior.
Yep, and if they're congruent, that must mean I got a set of lines that are parallel. In this diagram, what set of lines?
SP and MT.
There you go, Vinny. SP's got to be parallel to MT. That's on your own, guys. I got to see those are alternate interior, which makes those lines parallel. Look at the next given.
Wait a minute. Why isn't... I thought it was SN and PT that are
Whoa, whoa, whoa. Follow. Watch how I make these angles, Sophia. Boom. Boom. See how I just formed those angles? It's got to be on SP and MT. Okay, for those two. Got to be. All right, go to the other two givens. Or the other given, not two given. Other given. At TPX, everybody. This angle, congruent to SMX. That one right there. Look at those two now. Oh, I think I recognize those, what type of angles those are. So somebody talk to me here. What type of angles and what do you know from them now? Here we go. Going up, number 9. Here we go, Audrey. What type of angles are those two?
Also alternate interior?
Yep, but now it makes what lines parallel?
SM and PT.
There you go. So does everybody see, by giving you those two pairs of angles congruent, you get parallel lines, which gives you a parallelogram. That's enough information to say a yes. That's a parallelogram. Now your explanation. This is what we're going to put in the reasons column of our proofs in a couple minutes. Flip what you would have wrote yesterday. What property is being applied here? What property? I'm going to keep asking a ton of questions today. What property do I have right here? What did I just show on this quadrilateral? 24, Emily, what did I just show on this quadrilateral about the opposite sides?
That they're parallel.
Okay, so watch how I'm going to start this one. Good job, Emily. Opposite sides, parallel, imply a parallelogram. It's what we wrote yesterday, but in reverse now. I have the property that gives it a parallelogram. Good work, guys. Good work. Questions about that first one, why it's a parallelogram? Because some of these may or may not form a parallelogram. So let's go to the second one. And sorry if you guys have been doing this in pen, but I'm going to erase mine because I can. Let's get rid of all those. All right, we're ready to go. SX is congruent to XT. SM congruent to TX. I'm sorry, SM and PT. SM congruent to PT. Is that good enough to make a parallelogram? Well, we have marked right there. Remember, it's got to look like one of those 5 diagrams I started at the beginning. It can't be like a piece from here or a piece from this diagram. It's got to look like one of those diagrams. Do I have that right now? Do I have that right now? Let's see who's up. 15. Here we go. Will, do you think I have that right now on this diagram? No. Number 1, the diagonals are not bisecting each other. Only one's getting bisected. It's both. And number 2, both pairs of opposite sides need to be congruent. I only have one pair. Way to go, Will. So that's a big no spot. That not enough info. Almost, but not enough. Moving on. Any questions? You just open up your mic and let me know because I'm not looking at the chat at all. Next up. All right, what do I have? PX. Get rid of that marking. Come on. There we go. All right, kids. PX and MX, SX, congruent to TX. What do we think here? Good enough for a little parallelogram action. Good enough for a parallelogram. Who's up? Here we go. This is killing you guys. You can't see a darn thing, huh? Oh, Will, up again, number 15. Will, good enough on this one, Will?
Yes.
Oh, yeah. Why, Will? What am I showing you right now?
Because the diagonals bisect each other.
Great job. I'm showing you that the diagonals bisect. So ready? Diagonals bisect each other. Imply a parallelogram. Good job, Will. So we okay so far? One more to see if it makes a parallelogram. This is good practice going into our proofs. All right, next, what am I looking at here? I got SP congruent to MT. And I also have SP parallel to MT. All right. I'm not going to call on anybody here because it's the first time I'm showing you this. This is our special case, guys. This is our special case where one pair the same pair of opposite sides are both congruent and parallel. This will form a parallelogram. Okay, one pair, the same pair of opposite sides, congruent and parallel. So we're going to write yes, but I can tell you we're not going to write special case implies a parallelogram. All right, you'll be a special case if I see that written down. All right, one pair of opposite, that's the key word in here, opposite, not one pair of sides, one pair of opposite sides, congruent and parallel, imply a parallelogram. My writing is better on my Chromebook than it ever was on the TV. Not that anybody cares. Questions? You guys now are going to go on your own. You have 2 minutes right now to do 7 through 14. Do not, just so we can save time, do not write an explanation. Just write a yes or a no for me. All right, so go ahead. A couple minutes, 7 through 14. Again, just to save time, you don't have to write an explanation. We've written a couple already. Whew. All right, guys, what do you say? Just give me a no or a yes here. Number 7 here, problem number 7 here. A yes or a no. Here we go, number 12. Lucas, a yes or a no here. Parallelogram or not?
Parallelogram.
Yep, diagonals bisect each other. Everyone good? 8, did I give you enough information on number 8 here? Let's go with 17. Maeve, did I give you enough info?
No.
Nope. I need to give you both pair. One pair won't cut it, everyone. One pair won't cut it. Oh, look at 9. I got some markings on there, huh? 9. Is that enough to give you guys a parallelogram? Here we go. Number 18. Owen, enough to give you a parallelogram on 9? No. Guys, it has to be the same pair. The same pair of opposite sides need to be congruent and parallel. All right? It's a little tricky there. Good job. 10. Here we go. Let's go number 11. Anthony, enough to give you a parallelogram?
Yes.
Darn right. Opposite sides congruent. Good work. Ooh, number 11. 11. Did I give you enough info there? 14. Ellie, did I give you enough info there?
Yes.
Yes. Look, guys, I gave you alternate interior for these lines to be parallel and another set of alternate interior angles for these lines to be parallel. Good job, Ellie. That's a yes. Opposite sides parallel. How about 12? Enough info for 12? 19. Here we go. Sean, enough info? No. Remind you guys again, it's got to be both pair. One pair doesn't cut it. It's got to be both pair to create a parallelogram. How about this next one, number 13? Let's go 9. Audrey, back to you. Is that enough for a parallelogram?
Yes.
Yep, that's our special case. One pair of opposite sides, parallel and congruent. And you guys are doing a nice job. Let's finish it off strong. Number 14 here. Enough information. Let's go 2. Quincy, enough information?
No,
because there's only one side.
Darn right, I need both. All right, good job, guys. That was rapid fire. Everyone's following along. I love it. All right, you ready? We ready to dive into the proofs? I only got 2 today for you. Now we're going to try to figure out how we can make it a parallelogram. Remember, it's got to look like one of our diagrams. Opposite sides congruent, opposite sides parallel. One pair parallel and congruent. We got to do something to it. All right, and number 1, I know a lot of people are just going to gloss over this, but it's pretty important. I called PQRS a quadrilateral. It has no properties. Quadrilateral, 4 sides, angles add up to 360. That's all you can tell me. Don't try to apply a property to just a quadrilateral. You can't. It has no properties to it. All right, so that's all I know. It's 4 sides. So let's go to the other givens then. Angle 1 is congruent to angle 2. Stop. Everyone stop. Angle 1 congruent to angle 2. Can you come up with a conclusion right now that I can jot down in my statements? If 1 is congruent to 2, that means what else is true in this diagram? Here we go. 8. Ryan, you got a true statement. If 1 and 2 are equal, that means what?
PS and QR are parallel.
Great job. PS parallel to QR. I'll mark it down. I'll put it on my diagram. Good job, Ryan. It's maybe has been a while since we used this reason. Why are they parallel? Because alternate interior angles congruent imply parallel lines. Everyone's good. So I have 1 set of parallel lines, not a parallelogram yet. Not yet. Let's go to the other given. 3 and 4 are congruent. Stop right there. If 3 and 4 are congruent, you can tell me what? 20. Radhika, what is true if 3 and 4 are congruent?
PQ is parallel to SR.
There you go. PQ parallel to SR. And if you guys want to write a separate statement number 3 and write that, that's fine. It's going to be the same reason, so I'm just slipping it in there at number 2. Okay, so that's what I have so far. So I'm going to stop right here and ask somebody, is this enough to say it's a parallelogram, what I have right now? Is this a parallelogram or do I need more info? Let's hear from Radhika again, number 20. Enough info, Radhika, to say it's a parallelogram?
Yeah.
Darn right it is. So here we go. Number 3. PQRS is a parallelogram. And I think it was this class who asked yesterday, if you want to use the symbol, I'm not going to fight you with it. But please, if you're going to use that symbol, it's exclusively to say parallelogram. When we start rectangle and rhombus on Thursday, I can't use that symbol for that. It's exclusively for a parallelogram if you guys want to use that symbol. Is a parallelogram. All right, somebody new now. Why is it a parallelogram? What do I have done here? Let's go 25. Sabrina, why is this figure a parallelogram now? What does it have?
Opposite sides are parallel.
Unbelievable. Good job, Sabrina. Opposite sides parallel imply a parallelogram. You guys are on fire today. All right. Whew. Questions there from you guys? Anything I can answer? Not too bad. I know 3-step. I always have a nice, easy one for you to get your feet wet. Not saying the next one's going to be difficult, but any issues you want to ask here? Okay. Let's try this one out. This one's a little, here's why this one might be tricky. Look at the givens. I'm telling you, ABCD is a parallelogram. So ABCD, the whole quadrilateral here, ABCD, that's already a parallelogram. So I can apply all my properties to that. But I need to know why EBFD, The quadrilateral inside it is a parallelogram. All right. So we need to get EBFD to look like one of our 5 diagrams we started with at the beginning of class. Also, let me mark in my diagram that AE is given congruent to CF. All right. So now here's where the mindset is. EBFD. Can I get a pair of sides congruent? Can I get a pair of sides parallel? That's probably where you want to start. Can anybody see how any pairs of sides could be parallel or congruent here? And remember, ABCD is a parallelogram, so maybe you can use some properties there. All right, so take a look at it before I call on somebody here. Can you get a pair of sides congruent or parallel in EBFD? Take a look. Because that's where probably, if you're going to make it into a parallelogram, that's where you want to start. Can I get any sides congruent or parallel? All right, here we go. Let me turn it over to the honors kids here. 26, Emma, how we doing today? Good, that's good. I'm doing well too. Thanks for asking. You got anything here, Emma, you want to go with?
Well, I was going to say DC is parallel to AB.
DC is parallel to AB. Got it. How is that? Okay, I'm just asking, Emma, because you could be on the right track. I'm not going to give anything away. If DC and AB are parallel, how's that going to get DF and EB parallel?
Because well, you can do then you can get the DF and the EB. I know what I'm thinking. I just can't
I got your back on this one, Emma. All right, and I was actually going to wait to do this at the end of the proof, but since Emma brought it up, I'm just going to do it right now. All right, it's a new theorem. That's Emma. That's why you didn't know the wording for it, because it's something I'm going to show you right now. Guys, take a look for me, please. Is everyone in agreement? I was going to show this at the end, but I'll do it right now. Everyone agrees DC is parallel to AB. Can we agree on that? Because it's a parallelogram. Parallelogram implies opposite sides parallel. Okay, we know that. So wouldn't it make sense for DF and EB to be parallel? Because they're on the same line. I just shortened it a little bit. Look at your diagram. DC and AB are parallel. I'm shortening it to DF and EB now. So shouldn't they also be parallel? They're on the same darn line. Everyone see where I'm getting at there and where Emma was going. All right, DC and AB are parallel. So just because I made them a little shorter, they should still be parallel to each other. And it's a new theorem. So what I'm going to say now is DF is parallel to EB. And here's a theorem I would definitely use now in these proofs. Parts of parallel lines are parallel. Parts of parallel lines are parallel. Make sense? If the bigger ones are parallel, the shorter versions should be parallel. Parts of parallel lines are parallel. So good look there. I'm a good look. So parallel. All right, let's keep talking. And we're going to write this theorem down in a minute because there's another version of it too that you may have to use on homework tonight. But everyone take a look at your diagram. DEBF. I have one pair of opposite sides parallel. I still need more to make it into a parallelogram. So here are your options, right? Here are your options. I have one pair that's parallel. Could I get the other pair parallel? That's an option to make it into a parallelogram. Or here's my other option, is that special case. I have these two parallel. Could I make those two also congruent? Then I would have a parallelogram. Those are my two options right now. Get the other pair parallel or get the same pair congruent. I think most of you would probably want to go one way over the other here. So what do you want to try to do? Get DE parallel to FB or DF and EB to be congruent? Where do you want to go here? Oh, what do you want, Maeve?
Congruent.
That's probably where I'd be going to. All right, because I'll be completely honest. I have no idea how I would get DE parallel to FB. I have no idea myself. So everyone, here's our goal. Can you get DF and EB to be congruent? Can it happen? It can. It can. You just got to see it now. How can I get DF and EB to be congruent? And by the way, there's no theorem I'm going to give you that says parts of congruent lines are congruent. That's a no shot. All right, there's no parts of congruent lines are congruent. All right, how are you going to get them congruent for me? Here we go. Who's got here? Let's see. Boom, number 16. Here we go. Kyla. I don't think she's here. So somebody else.
I'm here.
Oh, Kyla. There we go. Sorry.
No, that's okay. Both of the lines, if a pair of opposite sides are congruent and parallel.
Yeah, I know, but that's where I'm getting at. How I'm trying to get DF congruent to EB. So I have that property you just gave me. That's what I'm asking you right now, Kyle, is how can I get DF and EB to be congruent?
Subtraction.
Okay, good. Okay, I'm going to keep, I still need some little bit more information from you, Kyle. What are you subtracting FC and AE from?
DC and AB.
There we go. All right, everybody, I know DC is congruent to AB, and some of you guys are getting ahead of me, which is great. DC congruent to AB. Parallelogram implies opposite sides congruent. And then hopefully now you guys see the subtraction. DC minus FC equals AB minus AE. And things still don't change because after my subtraction reason will be substitution to finally get DF congruent to EB. Substitution.
The subtraction was the first thing I saw, not anything to do with parallel lines. Could you have proved also DE and FB congruent if you were to? I know it'd be longer, but couldn't you prove triangles DAE and FCB congruent and then prove the other pair of sides congruent?
That is the other way, Sabrina. That is the other way, Sophia. Yes. Correct. Yep. And I'll if you just missed what she said, it was pretty important. I'll go over it once I'm done with this proof right here. But yes, there is a different way of proving this a parallelogram. All right. So I got DF congruent to EB. Now I can say EBFD is a parallelogram. We do not write down special case. Is a parallelogram. Ready? One pair of, and here's the key word, opposite. One pair of opposite sides, congruent and parallel, imply a parallelogram. Okay. So let me go back to what Sophia just said. There is a different way. You could have proved opposite sides congruent. So one pair of opposite sides was done by subtraction like we did. And then how did you get the other pair of opposite sides, DE and FB, to be congruent? Prove these two triangles right here congruent, which you could. And then say CPCTC, DE was congruent to FB. And then you'd have both pairs of opposite sides congruent. So yeah, another way. I just wanted to show this way to show you this new theorem. And let's wrap this up before I let you guys start the homework. The two new theorems that you can now use in the proofs. One we just went over in the last one, which is parts of parallel lines are parallel? That's if you're given if the longer ones are parallel and you need the shorter ones parallel. Okay, if the longer ones are parallel and you need the shorter ones parallel. Now, what would be I don't want to say reverse, but go back to our diagram on the second proof, please. Just take a look at that diagram. Let's say I told you DF and EB were parallel. I told you DF and EB were parallel, but you guys wanted to say DC and AB. The bigger parts were parallel instead. Instead of using the word parts, I used the word extensions. Oh, that's pretty clever. Extensions of parallel lines are, God, what is going on? Extensions of parallel lines are parallel. All right, so depends if you need the whole thing or part of it. If you need the whole thing, use extensions. If you need part of it, use the parts. All right, go ahead, get going. Stay with me here. We're all going to stay on here together in case you come up and somebody has a question. Please ask it on the assignment as you're doing it now.